Hi Year 10, this is our third lesson for the topic of quadratic relationships. In this lesson we're going to learn how to graph parabolas. So this is what we've covered so far. We've learnt about quadratic relationships, and then last lesson we looked at parabolas. We learned how to find x and y intercepts, the axis of symmetry, the coordinates of the vertex. We talked about concavity and we looked at vertex form. So to graph a parabola we can either create a table of values and plot points, or we can use the features of a parabola. That's all the things we learnt in the last lesson: x and y intercepts, concavity, axis of symmetry, coordinates of the vertex. So let's start with the table of values method. Create a table of values for y equals 2x squared and graph the parabola. I always like to start at 0 because it's the easiest. When we substitute 0 in there, we get 0. Now let's do the positive numbers. Putting 1 in, 2 times 1 squared is 2. 2 times 2 squared is 8. 2 times 3 squared is 18. Now let's tackle the negatives. Remember, when we put a negative number in, particularly if we're going to square it, we should put it in brackets. -1 all squared, which of course is positive 1. So 2 times 1 is 2. And you can probably quickly see that this is going to be symmetrical. Now once we have our table of values completed, we need to just draw the graph. Don't forget to label the x and y axis and put arrows on the ends of your curve. Here's another example. Graph the parabola y equals 2x squared plus x minus 1. Here's our table of values. Same values for x. And let's start again at 0. Putting 0 in wipes this out and this one out, and we're left with -1. Now let's substitute the 1 in. 2 times 1 squared is 2, plus 1 is 3, take away 1 is 2. And substituting 2 in, we get 8 plus 2 is 10, take 1 is 9. And then finally 3, 2 times 9 is 18, plus 3 is 21, take away 1 is 20. Alright, let's do the negatives. Don't just assume that they are going to be symmetrical. In this case they're not. Put the -1 in. -1 all squared is +1. So this is 2, take away 1, take away 1, which is 0. Putting the -2 in, we're going to get 8, take away 2, take away 1, which is 5. And then finally doing the -3, 2 times 9 is 18, take 3 is 15, take 1 is 14. Now when we plot the points, we get a rather uneven sort of shape. And that's because the vertex is actually slightly to the left of this point. So don't just join these up randomly. Okay, you need to think about it. Even figure out what the coordinates are for the vertex or the axis of symmetry. It's going to be -b, so -1, on 2a. So it's -1/4. It's just this side. So when we draw it up, it's going to look like that. Remember, it's symmetrical about the axis of symmetry. So you really want it to be symmetrical about that line x is equal to -1/4. Now here's another trap for young players. Make sure you think about your x values. If we complete the table of values for y equals x minus 7 all squared, these are the numbers that we get. And if we graph them, we get that, which doesn't look like a parabola at all. And it's because the axis of symmetry is actually at 7. It's way over here. We haven't even got to the turning point. So it's probably wise with a question like this, especially if you're going to use a table of values, to work out the axis of symmetry and then pick points around that, like this. See how I've got 7 in the middle, and I've gone 6, 5, 4, and then 8, 9, 10. And I can see that lovely symmetry happening. So this is what the graph actually looks like. Okay, we're going to move on to graphing parabolas using the features of the parabola. Here's our example. Graph y equals x squared plus 6x minus 7 using the x and y intercepts and the vertex. So let's start with the y-intercept. It occurs when x is 0. So let's put x equals 0 in here and we get y is equal to -7. There's our y-intercept. If we want to work out the x-intercepts, we need to substitute y equals 0. So y equals 0 here. So we need to solve this equation. X squared plus 6x minus 7 equals 0. You can use the quadratic formula if you want to, but it's much easier to factorize. Now, using the null factor law, either x is equal to 1 or x is equal to -7. So there's our two x-intercepts. So our axis of symmetry is minus b on 2a. Substituting in, we get minus 6 on 2 lots of 1, which is negative 3. And then finally, substituting that back into the equation, we're going to get the y coordinate. Negative 3 all squared plus 6 lots of negative 3. Take away 7 gives us negative 16. So our vertex has coordinates negative 3, negative 16. So plotting these 4 points, we get this. And we know it's symmetrical about this point, so we're just joining it up like that. Now, if we don't have x-intercepts, that's okay. What we do is just find the y-intercept and the vertex. So remember, some parabolas don't cut the x-axis. Do you remember why? It's when the discriminant is negative. Like this one, y equals negative x squared plus 4x take away 9. Have a look. b squared minus 4ac, substitute in, we get negative 20. Okay, there are no solutions to the quadratic formula, so it doesn't cut the x-axis. So we're going to start by finding the y-intercept. It occurs when x is equal to 0, 0, 0, negative 9. So the y-intercept is 0, negative 9. Now let's work out the axis of symmetry. It's minus b on 2a. Substituting in, we get 2. And substituting that back into our equation is going to give us the y-coordinate for the vertex. So that's going to be negative 5. So here's the coordinates of the vertex, 2, negative 5. We also note that this particular parabola is concave down because it's got a negative x squared value. All right, so we've got y-intercept, we have a vertex, and we know it's concave down. All right, so I've got those 2 points. It's pretty hard to see the parabola from there. We know it's going to turn here, but here's the thing. If this is a point, then all the way over here, this is also going to be a point because of the symmetry. So now we've got 3 points. Now we can draw our parabola. Remember to curve it, don't draw straight lines. There it is. Don't forget, no matter which method you use, the vertex is probably the most important feature because it tells you the symmetry of the parabola. And you can use a mixture of the 2 methods. If you don't have enough features, plot a few points to see what's going on. Don't forget to put arrows on the ends of your graph and label your axes. Okay, in our next lesson we're going to look at transformations.